Hello everyone. In a previous presentation, I have explained you how to solve combined problems of UV, IR and NMR. So in this presentation, let's try to solve one more problem. Molecular weight is given 87, UV not lambda maximum not above 200 nanometer. There are several IR bands 3300, 2980 to 2880. You should remember that that is value of the sp3 hybrid carbon 1655, 1555 and 1219 centimeter inverse, and there are 4 NMR signals. Let us check all the signals one by one. 3H triplet, 3H singlet, 2H quartet and 1H singlet with a very high characteristic delta value. So, as I told you in my previous session, before start solving the problem, we should always remember the immediate data we can get from the problem. So, UV not about 200 nanometer. So, most probably the answer must have, or better to say, must not have dyne system, because lambda maximum value is less than 200 nanometer. So most probably pi to pi star or n to pi star, this kind of transition, UV transition must be absent. Triplet and quartet, we already know that. Together they indicate presence of ethyl group. And we will also remember that this 1H having characteristically high delta value. So keeping these things in our mind, let us solve the problem. As I already mentioned, not about 200 nanometer, this sentence indicate absence of conjugation. 3300 is normally indicating NH or sometimes also OH. So most probably these kind of problems are purely based upon the trial and error method. If it is not NH, then you have to try with the OH. 2980 to 2880 is sp3 hybrid carbon or alkane value for the alkane stretching. 1655 is for the C double bond O amide group, and 1219 is for the C single bond N amide or amine. Now let us deal with the NMR. So these are the four signals A, B, C, D. Signal A and signal C, triplet and quartet, always indicate ethyl group. So whichever group we determine, we will write its weight. So ethyl means 15 and 14, that's why 29. Signal B, singlet of 3H, delta is not very characteristically high. So that must be for the CH3 group, methyl group, and its weight is 15. Already in IR we have seen that C single bond N is present. You should remember nitrogen rule that I have already discussed in a previous presentations. Nitrogen rule states that whenever nitrogen atom is present and molecular weight is in the odd number, then number of nitrogen atoms also present in the odd number, or you should remember that reverse is not true. We cannot say that all odd number, all molecular weight with the odd number can have nitrogen in odd number. No. The basic thing is that first of all nitrogen should be present, and then if the weight given is in the odd number, then the number of nitrogen atoms also present in the odd numbers. And if the molecular weight is in even number, then Number of nitrogen atoms are in even number. Here, molecular weight of the problem is 87. So, nitrogen atom which is odd, that's why nitrogen atom must be present in the odd number. Now, whichever groups we have confirmed or identified, we will subtract them. So, this is 87 molecular weight given, from which we will subtract 29 ethyl group. So, remainder is 58. We have also confirmed the presence of methyl group. So, 15 is its weight. So, 43 left. Carbonyl group for the 1655 IR band. So, 28 of carbonyl. So, 15 is left. Now, there are two possibilities. To justify weight 15, there are two possibilities, either methyl group or NH group. Because here if we think about OH, then oxygen's alone atomic weight is a 16. So that is not possible. So, and methyl is also not possible because the fourth signal D, which is yet to explain, where only one H is mentioned. So, methyl group cannot present here because otherwise in the data of signal there should be 3 protons data must be given. So, for 15 we can say that NH must be present. So now all the 4 parts we have identified, their total is 87, ethyl group, 1 methyl group, carbonyl group and NH group, and we have to put them together in such a manner so that they the structure resultant structure should match with the data. So this must be the answer. Now always whenever we come arrive to the answer, we should check whether it satisfies the data or not. So first let us check. See, this is ethyl group, signal A, 3H triplet, here it is, signal B. Now that is 2H quartet, but that is our signal C. Then signal B is 3H singlet. Why it is singlet? Because in between there are heteroatoms, so coupling cannot present possible. That's why signal B is a 3H singlet. Here it is 3H singlet, and very high delta value of amino group is because of the yes, that is because of this amino proton. And name of this compound, if here it is a CONH2, then we could say it is a amide group. One of its hydrogen is displaced by methyl group. So we can say that this is N-methyl propanamide. So sometimes this happen, more than one kind of isomers are possible. So always after arriving the structural formula, one should check whether it satisfy or justify the given data or not. So I hope that you understand this problem.